Hey guys, we're going to do the friction lab. So open up the document and you'll see some introduction about friction, some pictures of the equipment we're going to be using, and a space for you to put a little bit of notes about measuring friction. So take a look back at the slides that we discussed earlier in class, and you can use those to help you, or you can use the textbook. But put like definitions, things like balance forces, what is friction, and contact forces. All right. Then you see this graphic organizer for the lab. You need to fill in the independent variable and the dependent variable for this lab. So remember what independent and dependent variable means. Independent variable is the thing that you are changing on purpose in the lab, and the dependent variable is the thing that you're measuring to see how it is impacted by the changes that were made in the independent variable. Then write a hypothesis. Remember, your hypothesis should be a potential answer to the research question. We're looking at how does the surface affect the frictional force acting against motion. And I'll give you some background here. We have these, it's a sled, paper sled, that we'll put flat on the surface, and some masses right here that will go on top of the sled, like so. And then we have a few, and I'm going to use this spring scale to measure the amount of force that it takes to pull the sled and get it moving at a constant speed, like this. Now, we have a couple of different surfaces that we'll be using. We have plain paper, we have a sheet protector, and then we also have some sandpaper. Each of these surfaces are very different, and you should be familiar, I think, with each of these, like paper, just a regular piece of white paper, plastic sheet protector, it's pretty thin, but it's a little slippery, and then rough sandpaper right here. So write a hypothesis about what you think the frictional force will be relative to the others for each of the surface. Which one will have the least amount of friction, which one will be the most, and which one will be in between. Remember to state it in the format of if and then. So if we do this and we change something each time, then we expect this to happen. Now come down to the data table. You need to give this data table a descriptive title. The descriptive title can come from the research question. I would just restate it as a statement instead of a question. And then we're going to fill in a few more things. So everybody in person got to pick 3 surfaces out of about 5 to choose from. I had to pick them for you. So we're going to do paper, we're going to do sheet protector, and sandpaper. So write those into your data table. Then you need to tell me what units we use to measure force. And I'll give you a hint. You should be able to see it on my spring scale. Do you see the capital letter after the numbers? Those are the units. It's capital N, which is short for newtons. You'll also see that in your notes. And we'll do 3 trials of each. So type in your descriptive title, put the units for force in each column, and then I'm going to do trial number 1 with paper. Okay. And scale. Pull it out at constant speed so you can see what's going on here. Ready? And pull. And that looks like 1 Newton. So you can put in 1.0 1.00 newtons for your first trial. 1.00 newtons. You don't have to put the N there because you'll have the units right up there. Okay, next trial. I think that one was about 0.90 newtons. And then third trial, I'll let you see this time. And that looks about 0.90 newtons again. You'll have to find the average of those three. All right, now I'm going to switch the surface to the sheet protector. You can see that. Do the same thing and pull. This looks like about 0.7. 0.7. Okay. 0.75. Yeah, 0.70 newtons. All right, we'll do it again. And that time is 0.65 newtons. Oops. 0.65 newtons. And next, .7 newtons for the third trial. All right, and now I'm going to switch the surface again to sandpaper. This is 100 grit sandpaper. All right. Take a look. And uh-oh. I need a different spring scale. I'll be right back. So I just switched my spring scale from a 2.5 Newton to a 5 Newton, and that should help me get my reading. There's just way too much friction for me to be able to use the 2.5 Newton one. Okay, there we go. This looks like 3.4 newtons for trial number 1. 3.40. All right, and trial number 2. It looks like about 3.3 newtons. And third trial. About 3.3 newtons again. All right, there's your data. You'll need to get the average of each of those trials. Then you'll need to create a bar chart. Your bar chart is just going to have each of the surfaces as a category and the average force needed for each of those surfaces. So 1 bar for each surface. I don't really care if it's a vertical bar chart or if it's a horizontal, that doesn't matter, as long as you have the 3 surfaces and then a bar for the average force on each surface. Insert your bar chart here and then answer the conclusion questions. Make sure you're including data from the experiment to support your answer. All right, guys, see you later.